Okay, so in this video, we're going to be reviewing a little bit of pre-calculus, some algebra on how to factor quadratic functions. Now, I know you know how to factor, but the reason that I'm making this video is A, your brain's rusty because we just came back from summer, but also B, to show you how I factor, because every math teacher factors a little bit differently, so there may be differences from how you see me factoring in class versus what you learned. The end result's always going to be the same. You're always going to get the same factors. But I just want to acquaint you with the way that I will be using in class, just so that you don't like freak out like, oh my god, that looks different, oh my gosh, it's nothing new, it's just maybe different from what you saw. Okay, very basic factoring, Smith style. So here we've got x squared minus 5x plus 6. And so we want to come up with two numbers that multiply to give you 6 and add up to give you negative 5. So the way that I do it is I draw this little x, and I put the product of a and c. So if we think of a quadratic as being ax squared plus bx. My pen is not playing nice today. Plus bx plus c. And then if we put the product of a and c on top of the x, so that's 1 times 6, so that's 6. And we put b, including its sign, on the bottom. We want two numbers that multiply to give us positive 6 that add up to give us negative 5. So if they multiply to give us a positive, and they add up to give you a negative, that means they're both negative, blah, 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 blah. So in this case, those numbers are going to be 2 and 3, because negative 2 plus negative 3 gives you negative 5, negative 2 times negative 3 gives you positive 6. And in this case, because our a is just the understood 1 in front of the x squared, then we can just take those two numbers and write x minus 2 and x minus 3. And in this case, that's it. It's factored. It's done. Again, that's because a is equal to 1. So if we move on to a slightly more complicated one, where the a term is not equal to 1, so here we've got an a term of 3, b is positive 1, c is negative 2. So with the x, we put a times c on top, so 3 times negative 2 is going to be a negative 6. On the bottom, we've got positive 1. So this time, because they're multiplying to give us a negative 6, we know that that means that one will be positive and the other will be negative. And so two factors that multiply to give you negative 6 that add up to give you positive 1 this time are going to be positive 3 and negative 2. Now in this case, because we have this a term, let me switch colors, of 3 right here, there's kind of an extra step that we have to follow. Which is that we have to come through and take both of these numbers and divide them by that 3. So divide this by 3, divide this by 3. So positive 3 divided by 3 becomes positive, well, it's not going to let me write it over there. Let's see. Positive 1. There we go. Over here, the negative 2 over 3 does not simplify. So the first factor, because it's simplified to just give us positive 1, it just becomes x plus 1 for our factor. The second factor did not simplify, so we have to move that 3 up to the front, so it becomes 3x minus 2. Another way you may have seen this done is that once you get, this is the same problem, but basically you get the negative 6 on top, the positive 1 on the bottom, you get the plus 3 and the minus 2, and you start off by writing it as if those are your two factors, and then you come through and divide by a once they're already written here. So you divide each of those by 3, and then you simplify the first one, it becomes x plus 1. Second one doesn't simplify, so you move the bottom up to the front, call that bottoms up. Do 3x minus 2. So either way you get the same result. I actually used to teach it the way that's on the right, but the way that's on the left is kind of easier to remember that 3 out in front, because if you go this route on the right, you may get here and then kind of think, oh, okay, well, I wrote 2 factors, that means I'm done. But that's not the right answer because you have to keep going. Okay, so that's basic factoring of quadratics, and that's how you're going to see me do it in class. You may have seen some different stuff. You may have seen some stuff with like a T-shape. That's fine. You factor however you need to factor. I just wanted you to see how I'm going to be doing it in class.